Hello, everyone. Today, I want to go through the broadcast process in the V5 indexer and first kind of step through it and then deal with some auditing that we need to do. So I guess first to set this up, there's kind of in Bitcoin, especially in BSV, there's kind of this gray area from the time a transaction is broadcasted from a user to the time that it is confirmed on the blockchain. Traditionally, this has been known as a transaction being in the mempool. BSV has kind of moved the chain forward, so the concept of what the mempool isn't the same as necessarily what it is or how it's thought of in BTC or Ethereum or other chains. But essentially, from the point that you sign and finalize a transaction, you can go through various steps of validation to give you more and more confidence that the transaction will get mined. But until some period of time passes and some processes have happened by a miner that puts it into a block and hashes it and provides the proof of work and wins that block, and that block gets built upon, in that time period, all you can do is get more and more confidence that a transaction will get mined. You can't know 100% for sure that it has been mined. So first I want to walk through here the broadcast system in the one-set indexer. So the first thing we do, obviously we've got our transaction coming in here. This is pretty modular, and although this interface might update over time, we've got our store, which is really where are we keeping track of our UTXOs and the things we know about. We're taking the transaction itself. We take in a broadcaster interface. The broadcaster is basically some mechanism by which a miner will receive a transaction from a user. And so this is an interface. This interface is built out in the Go SDK. Okay. So the first thing we do here is we look up all our transaction inputs. And in this case, okay, so transactions objects can have their, in the Go SDK, transaction objects can just be a raw transaction which only has a pointer to the outputs that are being spent as inputs, or it can actually contain those outputs within it. So this code does a little logic to basically figure out, okay, if I don't know what my source output was, then I'm going to go load up the transaction itself, and then I set the source output. So really that's just saying, get me the output script, get me the output Satoshi amount, get me all the information about this transaction such that I can validate it. And if this was broadcasted with a beef payload, those inputs would already be part of this transaction. So that would be populated. But if it's just a raw TX like we've done forever in Bitcoin, then we got to load those things up. Don't worry about height score right now. Okay. So then we kind of walk through a bunch of validation processes. At this point, this is not doing any fee validation. That will probably get added shortly. It's not that complicated. I just haven't gotten around to it yet. So I verify the transaction locally. I have a message for myself to make more descriptive error messages. Whatever. I'm not that worried about that. So essentially, this is going to verify all the scripts. So this combines all the inputs and output scripts, make sure that all of them are valid and pass. From this point on, so up to this moment in history, there is no changes in our database at all for what is happening in this flow. It's all just reading. So this is the first time where I actually set something. So I'm going to persist this raw transaction data to my database. That's simply such that if something breaks down and this transaction never gets broadcasted and I need to clean something up, I have it. Similarly then, so this is just about storing the raw transaction data in our transaction cache. Next part is we log the transaction. That's really just telling the system, hey, this transaction exists. So score we use throughout the system everywhere. It's really a sort mechanism. And scores, when a transaction has been mined into a block, are the block height and block index kind of put together to be one big value. But when a transaction is in a mempool, we're using a timestamp as the block height. But this is actually, we want to be able to track one more status here, which is at this point, this is only in the private mempool of the one set indexer. This is not yet necessarily even in any miner's mempools at all. And so with that, we're actually storing the score as a negative number. So essentially, if our score of something is negative, it means this is a small point in time. We're dealing with this transaction. We're processing this transaction. At the end of this broadcast flow, that score will be set positive, which means, okay, this is now in our mempool. But right now, the negative is just saying, I don't know what this is yet. This is a transaction that we've seen. We're in the middle of processing. But anything that's left with a negative score at the end of this process is something we have to clean up at a later point. All right, so I'm logging that the transaction exists. So I'm just logging the TXID and a score. What do we got here? Okay, so now is the point where we start actually processing this transaction. And there is a bit of a asynchronous thing that's going on here. And this is something that I want to walk through, and I might end up slightly cleaning up over the next couple days. Or it might be fine, and we don't need to clean anything up. So essentially, from this point right here, we have logged the transaction. We've logged that we're going to process the transaction, but we haven't done any actual changes to our database. That is where we start this process. So I guess before I get into that, I'll point out we have this rollback spends method. And what the rollback spends method does is it essentially deletes a transaction from our mempool. So if we're processing this transaction and we start writing data and something fails, well, that data is kind of half written. So we have two different mechanisms of cleaning that up. One is this immediate rollback spends. That just says, okay, this process failed, we got to roll things back. But if that process fails, we've still got incomplete data in our database. And that's where these negative scores come. So essentially, if anything is left with a negative score, what that will trigger us to do is to asynchronously in a background process out of band from the normal running of the system, will essentially do this rollback spends. But rollback spends here is a synchronous process where something broke, we clean up after ourselves, we return, and there's no issues. It's funny when I'm trying to look at the camera, I keep actually looking at my own picture in my screen. That doesn't help. Okay, so the first things we do is when we're kind of processing a transaction, we set the out point as being spent. That essentially moves the transaction output from an unspent transaction output to a spent transaction output. So all we're really doing here is saying this out point was spent in this transaction. So this added flag So set new spend here is it's an insert, but an insert of a value, I should say. But if we see, so this added will be true if the UTXO wasn't already marked as spent in a database. If it was already marked as spent, it means we're attempting to double spend the output. And so this will, first of all, if this added is false, it means we didn't actually set anything in the database. We haven't made any changes. So if not added, so if we weren't able to set it in the database, then we figure out where it was spent in. If that error is out, we roll back, and then and then the last check. So there can be processes where, let's say, a transaction is broadcasted to our endpoint, to our server. It goes through, it starts processing that transaction, something breaks down, it fails, can't clean up after itself, whatever. Worst case scenario here. That's all a lot of this coding is all just handling with the worst case scenarios. So if I get what transaction it was spent in, and that transaction ID is the same as the transaction that I'm currently working in, then it's not an error. It just means I'm picking up, it's kind of an idempotent process here. It's picking up where it left off. It's continuing that same transaction. So this is, I broadcast a transaction, something breaks, I get an error. My system then, the client system, tries to resubmit that same transaction. Well, we don't want the server to say, oh, these inputs have already been spent, because they haven't really already been spent. This is the same transaction that spent them, and we're just kind of cleaning up the process right now. Anyways, so if the spend, so if it is marked as spent by a transaction that's not our current transaction, then we roll back, we have an error. This is a double spend. All right, so once we've done this process, so this is, again, we verified the transaction up here. We then marked it all as, marked all the spends here. And then we actually go and broadcast it to our miner. At this point, again, they can give us a failure. And if they give us a failure, well, we need to roll this all back, because they're not going to mine this transaction. They've got some other validation that they have rejected this transaction. And so in that case, we got to roll it back again here. So this is essentially what we've got for a broadcast process. So what I want to work on right now is cleaning up two different states. One, when we're left with a state where the transaction has a negative score. So where it is in our mempool, or at least partially in our mempool, but it's not in, never made it to a miner's mempool. Oh, I should actually have gone over that. When we're done, oh, am I missing a piece here? Yes, I am. Good thing I looked at that. If failure else. Okay. That's what I was talking about here of once a broadcaster has received it and succeeded, then we need to set it as the positive score, so that we know, okay, this is now not just in our mempool, but in our miner's mempool as well. Oops. Okay, so what do I do in the error case in this? Actually, I think we don't really need to worry about if there's an error logging the status, there's not really anything we can do to clean that up. This transaction has been broadcasted. We weren't able to set its status as positive, but that doesn't mean that it isn't a real transaction. So if logging it with a positive score errors out, well, we're just having to clean that up when we clean up our process where we process transactions with a negative score. Okay, so so let's say func audit broadcast. We need a context on that, I'm sure. And that's it. All right. I need to step away for just like 1 minute. I will be right back. All right, I am back. Okay, so to search through this process, we're going to want to find, let's see here. So I want to go, okay, here's actually another problem. I need to have my TXO store. I guess I can just pass that in. I suspect there's going to be some, what's the word? Some kind of re-abstracting of this code done such that there's some sort of a context rather than passing these things around. But at this moment, I'm not actually that concerned about it. Okay, so I want to go store.search, search members. IDX TX log tag. Is that what that was? TX log tag. That really should be TX log key. Well, that's just a naming thing. I can get to that later. Oh, that's not even where this goes. All right, so I need a IDX search config key. And I think I should be able to say from actually to 0. Well, let me take a look at how I've got my search wired up here to make sure that's going to work. Let's see here. Search. Let's look at both the Redis and the Postgres version. All right, when I do search here, I might be making some assumptions that are not, oops. Oh, I don't think we even use this in Postgres. Not like that, we don't. Okay. So we're score. So if reverse, so I'm not reverse. Score. Okay, so I think what I actually want this to be in both cases. Let's see, from query, not reverse. If from is not equal to 0, then we default to minus infinity. Wait, what? So from is used for paging. So from you pass in when it's essentially the last element that you received on the previous page through here. So if it's not equal to 0, we set it. Otherwise, it's minus infinity. Okay. So in the case of Redis, minus infinity will work fine. In the case of Postgres, okay, so first of all, it looks like I don't actually have the to functionality wired up on either side. So I added this to 6 days ago. The idea was you could be more specific about kind of how you're searching through sets of records, but it looks like find all references. Okay, I just specified it here, but it's never been actually wired up. So let's, I guess, go back and wire this up. So again, it does matter. Reverse. No, it doesn't matter. Okay. Oh, wait a second here. Oh, this gets confusing with the reverses. Essentially, if we're going in reverse, our 2 is actually the minimum value, and the from is the maximum value. So let's do this. Okay, so if 2 and reversed, then min equals that. Else max equals that. Now, this parenthesis in Redis means excluding the value you're specifying. If I take that off, it will include it. So, okay, if I want to find everything less than 0, then if I put 0 as my 2, that will exclude 0. I think that's fine. On my max side of things, if I'm saying, I think I'm going to leave it like that. Let's see how this works. And then over here, what do I need to do here? So from let me see here. I probably actually want this infinity logic to work the same way between Postgres and Redis. Let's just copy this logic and comment out this logic for right now. So from a from standpoint, if from is not equal to 0, then let's say okay. So if we have a from specified, then we're going to check it in the system. We're going to make sure that our value is using that from. Otherwise, we just don't even specify. That was max. Oh, that's only because I'm going reverse. Oh, wait a second. Reverse means I want score less than. That's actually right. Okay. Otherwise, I don't care. And the min, in this case, I also don't care. So for forward, it's going to be a greater than. Okay. So now if our 2 is not equal to 0, then okay, so these parameter numbers need to reflect the same parameter length that's in this args array. So for me to do the same kind of thing, let's say param, no, let's say does string builder have any sort of a format function built in? Probably not. So let's go format dot s print f Okay. So if I'm saying 2 and it's reversed, then this is going to be a greater than. Otherwise, well, okay, so I'm saying I'm saying my score is less than if reverse, greater than if a forward. In a 2, we're saying greater, yes, and this should be less than. Okay. I think that logic works. Let's try it out. Got my spaces. Actually, I'm going to slightly redo this logic. If pfg.from is not equal to 0. Okay. So if we don't specify a from, we don't worry about any of this stuff. If we don't specify a to, we don't worry about any of this stuff. And just to be uniform, and so I can put other stuff in there. Okay. I kind of have a pattern for whenever I want to modify this SQL statement on the fly. And length, yes, that is going to be. So parameters in Postgres are 1 based counting, not 0 based. So our length, no, our length is not going to be right. Okay. So here's my, at this point right here, I have 1 arg in my list. Okay, it actually works just fine as long as we've added the parameter to the argument list, or added the argument to the argument list before we determine its output number. That will be fine. So this is 1. I add a second one. This is 2. I add a third one. This is 3. Okay, that works. Okay, so how do I want to access this thing to test it out? Well, actually, let's go back over here. Forget about testing it out. I'll do that later. So I want to say 2, 0. From is undefined, which means it's going to be minus infinity or not even specified. Actually, I think that's it. I just want to find all transactions. So this is going to give me, not in JavaScript, PXIDs, error, Jeez, oh Pete's, my brain is not with it here. Right now, let's just print them out. Okay. So I'm gonna, let me see here. Let's go over to my server. Actually, let me go to my broadcast. Let's say, okay. Go back over here. I'm actually going to return from this thing for right now. I'm going to totally work through this, but we're going to have a array of strings. Okay. What? Oh, forgot my end bracket. Okay, so let's say get audit. Okay. So I happen to know. Now I'm not sure this is set up right yet. So I'm going to actually probably mock up some transactions. So this right now is configured to go against my Redis setup. Let me go to my .env file. Okay, I do have my Postgres database wired up in this environment. Let me make sure that's the right one. Why can I not see? What? I have actually got what is going on here? Oh, sorry. There we go. Fighting with my computer. Okay, I'm actually gonna change this connection string off screen. And then I'm going to, let's see here. I'm going to set a score negative in the database. Okay, let's see if this works. So if I go server, actually, I'm not positive that my server is using this config file for its so that config is just kind of a way of defining one set of indexers and TXO stores and everything that can kind of be called in throughout the entire system. but I'm not absolutely sure that that's what I'm doing here. Config.network store. Oh, okay, that would have worked, but I've got it there. Okay, I got something wrong. Redis TXO store. Where is that being called from? Because I just deleted it here. Oh, I didn't actually change it here. I believe it is called Postgres full. Boom. Okay. So now let's try. Cannot get. Oops, that should be V5. Okay. No transactions coming back. TX. I saved that. So let's go. I'm going to add another property to our search config, which is just verbose Boolean. And then over here, oops, if cfg.verbose, then log.println and then I want to set that verbose true for right now. So I can see what the query actually is that it's generating. Okay. Select logs.member, logs.score from logs. Ooh. TX. Args. So my 2 never made it through. Because I said 2, 0. And 0 is what I'm checking. So I can make this. Maybe I should. Let's go back to my search. Go away, go away. Search config. I think I actually want to make these from and to into pointers. So they can be undefined. And if you specify a value, that is the value you want to use. So not equal to nil. Going to be read through from not equal to nil. And then the same thing needs to go for the Redis one. Ooh, now we get some problems. Oh yeah. So every endpoint that calls these is going to need to have logic. Which might mean I need to rework some of this stuff. So this is right now assuming that if you don't specify it, it is 0. Well, I think that's actually going to be fine. I just need to do my logic differently. Don't worry about the inner workings of these methods right now. It's yeah, or feel free to, but I'm not going to go into them right now. Too big of a distraction. Okay, so I got that. I got that. I already did that one. I already did that one. Oh. Which means 2. Missed one. Oh. Owner UTXOs. What on earth? I don't know what that was trying to do. All right. We run. Score is greater. No, score is less than 0. Huh. And search key is TX. So I'm going to go just do a little search in my database here. Let's copy this. Sorry, I can't actually, the database is not something that can actually be public right now. Not for the scheme or anything, but for the, I'm working with client sample data and I don't want them to be concerned that I am being careless with their data. So score is less than. Okay, this returns a record for me, but it does not here. So search members. Oops. Let's actually go to. I'm going to stick a nice little breakpoint in here. We're going to stop running it this way. Go to server, and we are going to run it this way. Uh-oh. Oh, that is the wrong server file. Command server. Command server. Debug. Okay, we're going there. What do we got here? Okay, score is less than D. Print it. Search key equals TX. Score is less than 0. When I run this query directly on the database, it works fine. So something else here. Oh, I wonder if building that string builder twice might actually... I doubt it, but let's just do this just in case. Okay, let's try again. All right. Uh-oh. Limit is not specified, so well, it shouldn't really matter, but what is the result that I'm scanning this into? PG result. Where is result? Results. Oh, right. Literally the line that I'm highlighted is what I was looking for. All right. So my result here, I have an out point, I have a minus score. That part works. Okay, so I return that. Oh, shoot. This was part of some other code that does not belong anymore. So I explained this before. So we're using very much just generic indexed lists of data that are queued, or they're basically a key, and then I have all my results, and those results within that, it's a sorted set is what it is. So it's like an item, a member can only be in the set once, but it will also have a score tied to it, which orders it within that set. So some other things that were being done otherwise made some assumptions of whether I was. So there are some places where actually only in one case, for keeping track of what transactions are associated with a given user. Out points and transaction IDs are all stored in the same collection, the same sorted set, sorted by when those things happen. This method used to be far more specific than what it is right now. And so there was some logic that needed to be put in here for stripping out transaction IDs when I'm only looking for out points. This sounds complicated and like a mess. It really isn't, but this is a remnant bit of logic from previous go rounds. So I used to have search members and search out points. And I consolidated those, and I think what the answer is I should not have consolidated those. So let's find, before I do anything else here. Yeah. Stop my debug session. Is this my Redis one? Yes, this is my Redis one as well. Okay. So all I really need to do here, let's find everywhere I'm using search members. Search TXOs is going to be one that uses search out points. This does not care about, okay, and balance, that's going to need to get reworked anyways, but that one also only cares about out points. Probably means the same thing is true here. Oops. And oh, I'm only looking at the Redis one right now. Ingest. That should be members. Fund. That should be out points. Oh yeah. Before I go any further, TXO store. Okay, that one's fine. That one's going to be out points. That one's going to be out points. So let's do this search again. Search Redis store, search members, ingest and broadcast. Ingest. Yes, that's looking at TXIDs. Sorry, I realize this isn't probably going to make sense to anyone who isn't deep in this, but that's how we got to deal with this right now, because it is far more, I've got work I've got to get accomplished here, and I can't go into the details on everything. So if you've got questions, feel free to reach out to me. Love to talk through this stuff more. I'm even happy to talk through things interactively on a stream to help everyone. And I know there's been a little bit of interest in that out there. So really the facilitation is the hard part for me. So, I mean, if you've got questions and we want to do a live stream, I've got StreamYard. I can send you an invite. We can do a live one. And that might be kind of fun. So if anyone's interested in that, let me know. All right, I think we've got our issues resolved here. So let me go back to my server. Oh, actually, go back to my search members, and I got to remove this logic, and I'm going to rename this variable just to make it clearer what it does. Same thing here. Okay, so for Redis, I need this because it's just mapping data. Their data comes back as a Redis Z object, and I'm trying to return it as just a string. So members. But actually from no, okay. we're good. Everything's good. Okay, save. Move this over to the beginning so I can keep track of it. Actually, we're just going to go close others. Okay. Dope. Oh, I think I might have been. Yeah, I had the wrong file highlighted. So now, boom, let's just let it play through. All right. That's probably it for this session. So basically, we've kind of reviewed what builds the logic for this audit process. We've got the first part now where it is auditing what transactions are in an unknown state for it to clean up. I will come back a little later with part 2 where we actually start cleaning this up. But I actually want to give this a little thought rather than just fumbling around on a live stream. So yeah, that's it for now. I shall be back another time.